I am Dave, and you are not. Uh, the big news out of the old Caribou Daytime channel the last 24 hours was last night I thought I'd clean up my system a little bit, and I inadvertently completely blew away all my virtual machines, including my Windows 11 machine that contained all my data and code and stuff like that. But you know what? The data and code isn't that important because it's not production data, right? So it's not production data. So therefore it doesn't really matter. So what I've done is I went back and on my base system, which you see here, the base operating system, I installed all my Microsoft products: Office, Visual Studio, uh, Power BI, and of course, as you see, SQL Server. I got my ARM or Python environments on a virtual machine, an Oracle a virtual machine running Arch Linux, and I also got the latest Beta 5 of Haku OS installed also. So stay tuned for some videos about Haku, okay? And of course for more Python and R. Of course, the big news out of the R side of this channel is we began doing our series of data cleaning exercises using R and Tidyverse of the cleaning the cyclistic bike share data. So be sure to go and check that playlist also. That actually has its own channel, the Cyclistic Bike Share Project channel. So by all means, go subscribe to that channel, watch the videos, give them a nice thumbs up, and so forth. Okay. So anyway, let's get started with our data tonight. Take a quick look at the data. This is pizza sales. So you can see we got all the goodies here. Customer ID, name, so forth, postal code, region. This is, as you can see, this is a furniture sales business, okay? Product name, quantity sold, discount, and profit, okay? So let's just begin with our first question. Calculate the total number of unique products sold within each year. Okay. So that simply be select. Did we have a year column here? I don't think we do. No. So we can we do this? Let's see. Or do we have a year function? That's right. We have to use a top up here, don't we? Okay, so we do have a year function. So let's just say product name. So it says calculate the total number of unique products sold within the last year. Okay, rank is a problem. Rank has to do, well, rank can mean different things. Okay, anyway. Does that mean you actually want to rank 1, 2, 3, 4, 5? Or you simply want the high margin products sorted by that number? Okay, so anyway, let's do this. A little Okay, so is it looking for the product name? Yeah, and we can't use this, okay, because the get date doesn't work. This certainly is an interesting way to do it. Now, the trouble is, the trouble is, it doesn't say actually list the products. It says calculate the total number of unique products. It doesn't say actually list the products though. $315 unique products. So profit margin should be uh, total sales minus discount should be the gross profit. That doesn't change. Okay. So how do you know what the profit margin is? Because these are sales and not profit. So I mean, what would you do? Would you sum the would you calculate the profit and do a sum by product, or would you calculate the average sum by product? Uh-oh, looks like we're using a common table expression here, done it. Hey, going a little high. Now, you see, the trouble is this. Do they actually want a list of 1, 2, 3, 4, 5, or do they simply just want the top 10 products? That's the question. I actually am using the newer version, but I'm more familiar with the tops. Okay. Up here, what do up here? They said offset 0. Starts from the first row, from the first return row, right? And then fetch the next 10 rows only. Okay. Well, let's try this. Let's see if this will work. Okay. Again, it's a common table expression. So what it does, let's run this right here and see exactly what we got here. Okay. So we got product name, so sum profit divided by total sales gives us the gross profit margin. Okay. So it's taking the output from this, right? It's taking total profit, total sales, and profit margin. Then it's ranking them. Then it's using the window function to perform the rank. I'm not sure if that's really necessary or not, but we'll see. So let's see what happens here if we do this now. This should work. Yeah, it does work. 10 rows. Okay. So this is interesting. So the product with the highest profit margin is the GE 48 for less than 2. It has a 48%. Let's see something here. What do I want to do here? Let's see. Can we do this? And there we go. So that does work. But let's go ahead. Let's just go ahead and include the second version here also, because you know this is probably if you're new to SQL Server, this is probably the one you're going to see most, simply because it's been around the longest. Okay. And we get the same answer. Very good. Calculate product sales velocity by determining how many units of each product are sold per month. How many units of each product are sold by month? So, product name, units probably means quantity. Well, that looks reasonable to me. Well, I would have never guessed this one. Come up here. Hmm. Now, is this actually the correct answer? I'm not really sure. Is it possible it's making it too complicated? Another common table expression. Now, I would have no idea that this is the correct answer for this, okay? Because I'm not sure what that means. Does that mean that? Well, I honestly don't know. Let's see. The query calculates sales velocity for each product, which is the number of units sold per month based on the sales data. Number of units sold per month. Okay. The sum of the total quantity, total months. This indicates the number of months over which a product was sold. It is calculated by finding the difference between the first and the last date for each product. Gold. It represents the period during which the sales occurred. If the sales of a product span January to March 2022, the value would be 3 months. The +1 adjustment in the query ensures that the sales occurring with the same month are counted as 1 month. This calculates sales velocity, which shows how many units of the product are sold per month on average. Product A sold 600 units over a period of 6 months, which is a sales velocity of 100. Product 2 sold 300 units over the same period, over 3 months. The output product ranks based on the sales velocity, helping you to understand which products sell the fastest per month. This insight can be used for inventory management, marketing strategies, or a forecasting method. This query is particularly useful when looking to identify a high turnover product. Well, I don't think mine's correct then. All right. Interesting. So where are we here now? 2 to go. Identify which products have declining sales or have not been sold in the last 6 months. Okay, to identify products with declining sales or products of no sales in the last 6 months, you need to solve the problem in 2 parts. Products with declining sales, you can analyze sales products over different periods. Products not sold in the last 6 months, to find their products in order days. This part calculates sales for each product in the last 6 months. This part filters the products based on the other sales. Nice little case function here. I would have I would have no idea how to write this query. Okay, no idea whatsoever. Even if I was using it every single day, using SQL every single day. So this is a case function. Let's just see what this looks like. Last order date, recent sales, previous sales. Interesting, okay. We come down here, we do some more fancy stuff down here. No sales in the last 6 months. Okay, we need to change the dates. Because the trouble was, it's using the current date. Well, the current date isn't what we got, so everything showed up as no sales because there was no sales at all since 2017. Okay. So let's come back up here on this one again. Previous sales, it must be 6 months. See, and here's the dilemma again. I mean, why sit there and agonize over this? So we do have some declining sales, okay? Let's take a look at the documentation for this. Okay. End date changed to 12/31, calculates the date 6 months prior to 12/31. This is used to find sales within the last 6 months of 2017. Calculates the date 12 months prior to this, and this helps us compare the sales from 6 to 12 months. Last order date. This checks if the last sale for the product occurred before June 30th, 2017, meaning no sales in the last 6 months. Okay, stable or growing. This query still looks at the products with declining sales or no sales. Okay, so again over here we have declining sales but no increasing sales, which is not good. Excellent. Okay. Now, see, here's the dilemma with it's not a dilemma with me, and it's probably not a dilemma for the stakeholder. But you know what? Are they going to pay me their $60,000 a year to use ChatGPT to write queries? Well, I'd have to have additional skills, whether it's something like R or something like Power BI or Excel in order to justify, mid 5-figure incomes, okay? let's see what this says. Okay, however, if we don't have access to detailed inventory data or average inventory, we can use proxy for turnover. We can use a proxy for the turnover based on total number of units compared to the sales period. Assuming the sales table has relevant fields, category, subcategory, and quantity, we can create a report to calculate the total units sold for each product and subcategory, along with the time period over which the sales occurred. This will give us an idea of how quickly the product is moving. Again, so again, let's, oops. Now, I already told you this once, so why are you, how can we didn't see it from the previous one? So here it is again. Now, one minor note here, you notice that there's no semicolon to end this first query, because it's a subquery or not a subquery, but a common table expression. This is really, to a certain extent, a single query with two parts. Because see, you got the semicolon down here. So if you're using CTEs, do not use a semicolon either here or here to end the query. Okay, you place it at the very end of your query. This metric shows how many units of each subquery are sold per month. 100. Give me an insight into how fast inventory is turning over. For example, phones in technology category had over 150 units per month, while chairs turned over 100 units per month. Okay, good. And there we have it. So the one with the highest units, the highest turnover is tables. No, the highest turnover is furnishings, okay? Followed by chairs. All right? And there you have your ChatGPT / SQL Server database work for tonight. That is requirement of project number 5, I think it is. We have 4 more to go, okay? Thanks so much for your time, folks. And we'll see you in a day or two.